push-pull students, all set for the NSEP exam. Now, during these last few weeks, we are definitely going to work on a lot of PYQs, and in that series, we are going to solve some collision mechanics problems today. So, before that, a little bit about me. My name is Bhavdeep Sethi, and I have been converting a lot of physics haters into physics lovers. And I always say, never memorize physics. Physics को रट्टा मारोगे तो physics बुरा मान जाएगी. Now, if you were expecting spoon feeding here, then this session is definitely not for you, because in this session, I'm not going to present you the question and the solution. I'm going to teach you the concepts, and I would expect that you solve the question yourself. I will repeat that I'm going to present the question. I'm going to teach the concept. I expect that you solve the question yourself. So no spoon feeding. Now, exam is on 24th November, which is Sunday, 8:30 a.m. and we are all set. So let's start the practice. Now, the very first question, it says a neutron traveling with a velocity v and kinetic energy E has a perfectly elastic head-on collision with a nucleus of an atom. I mean, that's a typo from the book I copied that question from. It is from NSEP 2004, 2005. So a neutron, let's draw the picture here. So there is a neutron here. It's moving with some velocity v, and then it hits, and it has energy E, let's say, right? Now there is an atom here with atomic mass of A, and this is at rest. So this is at rest. So they say, okay, after the collision, and the collision is, by the way, it's perfectly elastic. So the fraction of total energy retained by the neutron is approximately. Now, if it is an elastic collision, definitely there is no loss of kinetic energy. So the total energy before and after is same. Then also the coefficient of restitution is 1. A lot of beautiful information there. Now they're saying atomic mass of this is A, and they're talking about approximations there. So I can assume that if this were 1 unit of mass, this is A units of mass, because what is the atomic mass or the mass number? It is the number of protons plus the number of neutrons. Mass of protons, neutrons are different, but approximately same. So number of protons plus neutrons is roughly all of them were neutrons. So if this is mass 1, this is mass A, right? So let's see what happens after the collision. So I know this is going to rebound back, but let's not assume that. Let's say it goes in this direction, because the equations should take care of themselves, right? So this is velocity v1, and this atomic number A goes with velocity v2. I know for sure if it is elastic collision, then coefficient of restitution is 1. What is coefficient of restitution? Coefficient of restitution is how fast are they separating divided by the velocity of approach. So velocity of separation divided by velocity of approach. So velocity of separation would be v2 minus v1, and velocity of approach is v minus 0, because this is not moving. So I know v2 minus v1 should be equal to v. So this is the velocity of separation, how fast are they separating, and this is the velocity of approach. So I know these two numbers have to be same because it's perfectly elastic. I know whether it is elastic or not elastic, momentum has to be conserved. So I know one thing, that momentum of this system before and after should be same. So I know v1, assuming its mass is 1 unit, the momentum is v1 plus, if this is 1 unit of mass, this is A units of mass. So A times v2 should be equal to the momentum of the system before. So this doesn't have any velocity. This is v, because 1 times v. So that's another thing that I know. Now two equations, two variables, v1 and v2, I can definitely find. I should be finding v1, because ultimately they want to know how much of kinetic energy is left here. So let's solve this. So v2 is, so this implies v2 is v plus v1. So I can plug it in here. So v1 plus A times v2 is v plus v1. V plus v1 is equal to v. So this is v1. I factor out v1, 1 plus A. And then this v goes on the other side. So v times 1 minus A. Wow, what a beautiful equation. So v1 is coming out to be, so I know v1 is equal to 1 minus A divided by 1 plus A times of V, and this is your answer right there. How much is the kinetic energy now? The kinetic energy now is half mv square. Mass is 1, so v square, the velocity square here. So 1 minus A over 1 plus A whole square v square. So initial velocity was half v square. Now this is half v square times of this. So this is your answer. So which one? Option A. Isn't it easy? I mean, NSEP 2004, 2005 question. Okay. A sector of mass m. I like this question because it's so beautiful that it can be solved in 2 seconds. But still, we'll follow the entire process here. A sector of mass m cut out of a circular disk of radius r is revolving about an axis perpendicular to its plane and passing through the center of the disk. If the angle of the sector is theta, the moment of inertia of the sector is by color or texture भी दे देते. I mean, what I mean is, I mean, they're giving so much of information that I don't need. So let's say what they're saying is, let's say you had a disk here. Now from this disk, you cut out theta, and then they're saying the mass of this theta is m. They're saying how much is the moment of inertia of this thing. The whole of thing is discarded. Only this thing is kept. So what they're saying is, okay, you discard the. Okay, I cannot do that with the board I have here. So but this is what you retain, and they're saying how much is the moment of inertia of this thingy. Isn't it so very obvious because of the symmetry here? See, the whole point is, how did we get mr square by 2? We know some molecules here, some molecules here, some molecules here, some molecules here. The whole of this thing adds up to that, right? So we know the whole thing, if it were mass m, the moment of inertia is mr square by 2 because of the contributions there. Isn't that the symmetry here? If this tiny sector has a mass of m, I am expecting that the moment of inertia should come out to be mr square by 2. But let's see. Let's not make any assumptions here. So let us say I have this thingy. I have this as theta. So let's say this angle is theta. And then I know, first of all, I should be finding the mass of this, right? Because how do I find the, so let's start. So how do you find the moment of inertia? You find the moment of inertia by doing the integration of dm times the distance of that square, right? So that tiny little mass you will take here and then distance of that square, and then you do the integration. So let's start with that. So let's say at a distance of x, I take a tiny little strip here of thickness dx. So how much will be the moment of inertia of this part? This part would be whatever the mass of this is. And because it is so thin, it doesn't matter that some molecules are close and far. That doesn't matter. It's infinitesimally small. So the mass of this times x squared. But how much is the mass of this? Mass of this would be the area of this multiplied by the area density. Let's call it d. D is the mass per unit of area. So how much is the area? Area is basically the length of this arc times dx. How much is the length of the arc? Length of the arc is x times theta. That is the definition of theta. So x times theta will be the length of this. So how much is the length of this? This is x times theta times dx. Isn't this the area of this? But that area has to be multiplied by the density. Let's call it rho, or sigma looks better. So let's put sigma. Sigma is the area mass density. So this is the dm. Now you multiply the dm with x square. So this is the contribution of this little mass to the whole of moment of inertia. But I don't need that. I need the whole of the thing. Then I'll integrate. What are the limits of integration? X is from 0 all the way to radius of that. So I'll say, okay, integration from 0 to r. Now from this, sigma is constant, theta is constant. So I can plug that out. So sigma theta, and then what remains in is x times x square x cubed. And Integration of x cube with respect to x is x4 divided by 4. Then you plug in the values r and 0. You get r to the power 4 over 4. That is the moment of inertia. But hold on, it doesn't match. And obviously, you have some variables like sigma that you assumed. Your final answer should not have any variable that you assume. Okay, that's fine. Let's find it in terms of mass. I have to bring in mass. So how do you find the mass in terms of all these? Do the same thing. Find the mass of this and then integrate. So what is the mass of this? We found the mass of that was sigma x dx. Oh, sorry. So my bad. X theta dx. So x theta is the length of this arc times dx is the thickness. So x theta times dx, this is the area of this times the density of that. That's the mass of this, but I don't need the mass of this. I need the whole of it. So then you integrate from 0 to r. Now sigma theta is a constant and the integration of x is x squared by 2. Plug in the values, you get r squared by 2. So this is mass. This is mass. So from this, you can factor out this thing. You can rewrite this as r square times r square. So by 2, you take this 2 here, you type 2 here because there was a 2 I borrowed here. So this thing can be expanded like this. So this is the mass m times r squared by 2. You are getting the same thing as what you expected by common sense, obviously. So that was my second question. Let's move on to the third question. A massless rope does not have mass, that's good, okay, is wrapped around a ring. So this is a ring with a groove along its surface, circumference, having a radius of r. So this radius is r and the mass of this ring is m. The ring is allowed to move downwards. The linear acceleration of the ring is. So see, if it were a free fall, it would have an acceleration of g, but not anymore because think about it, this tension is pulling it up. So let's think about the forces here. What are the forces? So I know there's a force of mg going down and there's a force of tension going up. Now this disk while moving down has two motions. One is it is falling down, but then it is also rotating. Why is it rotating? Because this is providing the rotational, and it is not slipping, so that those things are related. So let's start writing the equations. First things first, linear motion here. So I know there is a force mg down, there is a tension up. So I know definitely that mg minus the tension force should be ma. That's the very basic equation I can start with. That's mass times gravity is the force down, tension is going up. So overall force is mg minus t. That should be m times a. And this is what I have to find. This is what I have to find. But the problem is there's a variable t that's unknown. So I have to find somehow t. If I can find t and plug it in here, I can solve for a. Okay. Talking about t, isn't this t providing the rotation here? This torque of the t is the one responsible for rotational motion there. So T is the tension times the radius, that's the torque. Torque is the force times the distance there. So torque should be I alpha. Wow. Now what is I? I for a ring is mr squared. So let's write that. So TR equals mr square times of alpha. Now if there is no slipping, then I know A is equal to R alpha. Isn't it? I know that because if A is equal to R alpha. So let's say R alpha is A. So first of all, I can write this as TR is equal to MR R alpha. So let's cross out this R. So this R alpha is A. So then I know tension is equal to MA. And that's all. So what you do now is you take this thingy, you plug it in here. So what you get is mg minus ma is equal to ma. So this is masses cross out and this is 2a is equal to g. So g is equal to 2a or a is equal to g by 2. Again, students, this is NSEP 2006-2007 paper and you can see how easily you can solve these questions. It's not like it's an Olympiad question, it's a rocket science. It's a mix of easy, medium, difficult questions. You go by the common sense, you can solve any question. If you found this session helpful, first thing you do is you subscribe to this channel. Second thing, what you do is you tell your friends about it. Now, if you're looking for more practice, then I have started a course that is Achievers the Last Lap. In this, we're going to practice questions, questions, questions. The classes are going to be twice a week, Tuesdays and Thursdays. And the price is only 2222, but you can get 10% discount with this coupon code VSPRO1. And it's going to cover the full syllabus. And obviously, in 15 live classes, I'll not be teaching. I'll be doing the questions part, the heavy, higher level questions out there. So see you soon. Assignments are after every class. 5-part test, one full test means every Sunday will be the test. And this final test will be on 23rd of November, right before your final exam. So it's open for 10th, 11th, and 12th graders because these are the students who can give the NSEP exam this year. But now, if you're looking for a long-term batch where you are preparing for 2025 NSEP exam, then you go for full physics mastery. All the information is in the description down there. So I'll see you in the class. I speak less about me and my courses. I speak more about the physics part here. So I will see you soon, students, and good luck. Thank you so much. Take care.